All right, welcome to lesson 7 on simplifying expression notes. These notes may be a review for you, so you may need to scroll forward, fast forward, or rewind as fits your needs. Okay, so we're going to start by talking about simplest form. Simplest form is when there are no like terms or parentheses in your expression. Okay, so we want to make sure to use our properties to rearrange and combine all like terms. So if we look at example number 1, example number 1 is going to look like we've got 6n plus 3 plus 2n. All right, so in this case, we want to first identify our like terms. Well, we've got 6n and 2n that are like terms, so we can go ahead and combine those. 6n plus 2n is going to equal 8n, and then we still have our constant of positive 3, so we would just add 3 to that, and we've got a final expression of 8n plus 3. Now, you need to remember that you cannot combine coefficients and constants. Coefficients and constants together are not like terms, so this is our most simplified form of the expression. Next, for example 2, we're going to use the example 3x minus 5 minus 8x plus 6. So in order to solve this one, the best way to do this is to actually rewrite this, but instead of using subtraction, we're going to add the opposite. So we can do 3x plus negative 5 plus negative 8x plus 6. All right, now we can identify our like terms. So I'm going to use purple to identify my coefficients and combine those. We've got 3x and negative 8x. Well, 3 plus negative 8 is negative 5x. And then we're going to identify our constants, which together are also like terms. Negative 5 plus 6 is just going to be a positive 1. So our final answer is negative 5x plus 1, and that's our most simplified form. Now let's go ahead and move on to example number 3. Example number 3 is going to look like m plus 3 times the quantity n plus 4n. So what we're going to do here is we notice that we've got a expression inside of parentheses with a coefficient right outside. So we're going to eliminate those parentheses by distributing our 3 to everything inside. So when I rewrite my expression, I'm going to have m plus 3n plus 12m. Oops. Now, if I identify my like terms, remember like terms have to be from the same family, so they need to have the same variable inside. So the only things that I can combine are m and 12m, which would give me 13m. And I still have my constant, or my other coefficient of 3n. So my final solution would be 13m plus 3n. All right, let's move on to example 4. Example 4 gets a little bit harder because now we're going to be using the distributive property with negatives. So we've got negative 7x minus 2 times the quantity 5x plus 14. So the first thing I'm going to do is I'm going to rewrite my expression, but instead of subtracting 2 times the quantity, I'm going to add negative 2 times the quantity. So I've got negative 7x plus negative 2 times the quantity 5x plus 14. So I added the opposite here. Now I can go ahead and distribute negative 2 to everything inside of the parentheses, which leaves me with negative 7x plus negative 10x plus negative 28. Now I can go ahead and combine my like terms. Negative 7x and negative 10x are like terms. Negative 7 plus negative 10 is negative 17x. And then I've got my constant still of plus negative 28. Now, just like up here, how we got rid of subtraction by adding the opposite, really here we're still adding the opposite, which means we can rewrite this with just subtraction. Negative 17x minus 28, and that is our final solution. All right, let's go ahead and move on to example 5. Example 5 has to do with adding two separate expressions. So we're going to start with the expression 6x plus 4 inside of parentheses. And then we're going to add that to the expression negative 5x minus 7. All right. Now, in this case, since we're just adding one plus the other, we can really just pretend like the parentheses are not there. So what we can do now is combine our like terms, 6x and negative 5x. This is just going to equal 1x. And then we've got 4 and negative 7. 4 plus negative 7 is going to be negative 3, so we can add negative 3. And we can go ahead and simplify our expression because since we've got 1x, we really don't need the coefficient of 1. So we can just leave that as x. And since we're adding negative 3, we can just switch that back to subtraction of 3. So your final answer should be x minus 3. All right, moving on to example 6. Example 6 is going to look like x minus 3 times the quantity, x minus 4y. Okay? Now, in this case, we're going to go through and we're going to rewrite this, but we're going to add the opposite. So x plus negative 3 times the quantity x plus negative 4y. So add the opposite. Now we'll go through and we'll distribute our negative 3. So we'll end up with x plus negative 3x plus negative 3 times negative 4 is positive 12y. Next, we'll go through and we'll combine our like terms, x and negative 3x, while x plus negative 3x is just negative 2x. And we're adding our other coefficient of 12y, so you're left with negative 2x plus 12y. All right, we'll continue on the back side. So we're going to start with example 7. And example 7 is pretty simple. It's just got some subtraction in there that you need to be mindful of. So we've got 4y minus 2x minus 7 plus 2x. So we're going to rewrite this, but get rid of the subtraction by adding the opposite. So we're going to rewrite 4y, oops, that should be a y, plus negative 2x plus negative 7 plus 2x. Now we can go through and identify any like terms. Well, 4y actually doesn't have any like terms because there's no other y variable, but we've got negative 2x and positive 2x. Now, if you've got negative 2 and you add positive 2 to that, really that just cancels out to 0. So that's going to leave us with 0x. And remember, we like to put our variables in alphabetical order, so we actually want to put x first. We've got 0x, and then we've got plus the 4y, and then plus the negative 7. Well, since we've got 0 times x, really that just cancels out to 0. So we can just forget about 0x and write this as 4y. And instead of adding negative 7, we can just subtract 7. So you're left with 4y minus 7. All right, moving on to example 8. Now example 8 is the one that gets a little bit harder. And this is because in example 8, we're going to take two expressions and we're going to subtract one expression from the other. So we're going to start with 9 plus y minus 12 plus 3y. Now, do you see how in this case we've got one expression minus the other expression? So really what we have here is, let me rewrite this. We've got 9 plus y minus 12 plus 3y, okay? But really, since we're subtracting this expression from the second expression from the first expression, we can go ahead and we can, instead of having just the subtraction sign here, we can distribute that negative inside of our second expression by, instead of subtracting, we can add a -1, so add the opposite. And remember that since there wasn't a number out here, we can add a coefficient of 1 because of the multiplicative identity. 1 times any number or any group of numbers is really just that group of numbers again. So we're really just adding that negative sign to like an imaginary 1 that we can put there. Now that we have the 1, we can go ahead and distribute that to everything inside of the second expression. So we're left with 9 plus y. And once you distribute, you're done with all of the parentheses. So 9 plus y plus -12 plus -3y. And we can go ahead and identify our like terms. We've got 9 and -12, and then we've got y and -3y. So we want to do our variables and coefficients first. So y plus -3y is just -2y. And then 9 plus -12 is really just plus -3. And we can go ahead and rewrite this by getting rid of the adding the opposite. So we can rewrite it as -2y minus 3 is our final solution. All right, let's move on to number 9. Number 9 is really pretty simple. You just have to remember to distribute. And before you distribute, you have to remember to add the opposite. So we've got 2 minus 4 times the quantity, q plus 8p plus p. So in this case, we're going to rewrite this, but we're going to, well, actually, yeah, we'll rewrite this, but we'll add the opposite. So 2 plus -4 times the quantity, q plus 8p plus p. Now I'm going to go ahead and distribute that -4 to everything inside the parentheses. So I've got 2 plus -4q plus -4 times 8 is -32p plus p. Now I can go ahead and combine my like terms. P comes before Q in the alphabet, so we're going to take -32p plus p and combine those together. That leaves us with -31p. Then I've got plus -4q plus +2. And again, we can go ahead and get rid of adding the opposite and write subtraction there instead. So -31p minus 4q plus 2 is going to be our final answer. All right, moving on to number 10, we've got 7 minus 4 times the quantity, 2x plus 3 minus 6x. So the first thing we're going to do is rewrite this, but instead of subtracting, we're going to add the opposite. So 7 plus -4 times the quantity, 2x plus 3 minus 6x. Now we're going to go through and distribute the -4 to everything inside the parentheses. So we've got 7 plus -4 times 2 is -8x. Plus -4 times 3 is -12x. minus 6x, or I'm sorry, we should add the opposite, so plus negative 6x. Now I can go ahead and identify my like terms. There should not be an x here. I'm sorry. Let's get rid of that. That should just be a negative 12. Okay, so now if we go through and combine our like terms, we've got negative 8x and negative 6x. If I combine those together, negative 8 plus negative 6 is negative 14x. And if I go ahead and combine my constant of 7 and my constant of negative 12 together, 7 plus negative 12 is really negative 5. And again, instead of adding the opposite, I can write this as subtraction of negative 14x minus 5. All right, moving on. Example number 11. 11 says that we're going to have 2 minus 4. Oh, I'm using the wrong one. My apologies. Number 11, we're going to have 8x minus 1 times the quantity 4x minus 2y. So what I'm going to do here is rewrite this, but instead of subtracting, I'm going to add the opposite. So I've got 8x plus negative 1 times the quantity 4x plus negative 2y. Now I'm going to go ahead and distribute my negative 1. This leaves me with 8x plus negative 4x plus positive 2y. Now I can go ahead and combine my like terms. Remember, we like to go in alphabetical order, so we're going to do x first. 8x plus negative 4x is just positive 4x. And then we can just add our 2y. And remember, we can't combine those because they don't have the same variable. They're not from the same family. All right, and last but not least, example 12, we're going to have 19 plus 12y minus the expression 24 plus 5y. All right, now again, since we're subtracting one expression from another expression, we can rewrite this and get rid of the subtraction by adding a negative 1 here. So I'm going to rewrite this positive 19 plus 12y minus 24 plus 5y. But instead of subtracting, I'm going to change that to adding a negative 1 there. And then what I'm just going to do is distribute that negative 1. So now once I distribute, I can get rid of parentheses. So now I'm left with 19 plus 12y plus negative 24 plus negative 5y. And I can go ahead and combine like terms. I'm going to do my coefficients first. 12y plus negative 5y is going to be 7y. And then I've got 19 plus negative 24. That's going to be plus negative 5. And last but not least, instead of adding the opposite, I can change this to 7y minus 5. And that's my final answer. Go ahead and try some practice. Make sure that you're checking your answers either with your instructor or with the answer key. And be sure to ask your teacher if you have any questions.